Hey, what's up? I'm Will from DevOps for Developers, and this is the Week in DevOps. So I did a video not too long ago where I talked about just different things that I do during the week doing DevOps. It was well received, and this has been kind of a cool week, so I thought I would do a follow-up to that and see if that's something that y'all enjoy. So we're going to talk about two things in this video that happened this week. Both of them relate to protecting publicly exposed endpoints, and one of them relates to a scenario that you've heard about in the news with OnlyFans. And I didn't do any work for OnlyFans, want to be right up front about that, but this parallels along with it and makes a nice talking point to talk about some of the different things that you get into when you do DevOps. So one of my clients operates out of AWS. They have their code in a GitHub repository, and their CI/CD solution is a Jenkins server inside the VPC protected behind the firewall. So whenever something happens in GitHub, it needs to trigger a build over on that Jenkins server, right? So we rely on webhooks from GitHub to trigger those builds in Jenkins, which means that that needs to be publicly exposed. The Jenkins server needs to be publicly exposed. But here's the thing with that. If you operate in AWS or Azure or GCP, everyone in the world knows what those IP addresses are, and they're going to just beat on them all day long. The script kiddies are just going to relentlessly beat on those until they find a weakness. So for anything that doesn't have to be publicly exposed, it shouldn't be publicly exposed. And then if it does need to be public, you can restrict who has access to it. And that's what we're getting into here. So we have a security group on the inbound routes for this Jenkins server that restricts external access to GitHub's IP addresses, which they publish. There's an endpoint, you can call it GitHub. It returns a list of their IP addresses, and it may change from time to time. It doesn't change very frequently, but if it does change and you get an endpoint call from something that you haven't whitelisted, it's going to cause that build to fail or cause that build to not be triggered, right? So we built a job that pulls the GitHub endpoint nightly, pulls down a list of IP addresses, and updates the security group in AWS to ensure that all of GitHub's IP addresses are whitelisted and can trigger builds on the Jenkins server. And it broke. It's been up and running for a couple years, but it broke this week. So I had to go in and dig through it and dig through code that I had written a couple of years ago, which is always fun. And that's when you really learn how good of a job you do at documenting the crap that you write. So here was the end result of this. We pull this endpoint, we get the list of IP addresses from it, and then if they aren't in the security group in AWS, we add them to it. But the change that was made over on GitHub's side is they started publishing their IPv6 addresses. And so the script that I had written wasn't expecting that. It blew up, and as a result, it saw that the IP addresses were different. The first thing it does is delete the existing IP addresses from the security group, which meant that nothing had access to Jenkins, and therefore all of the builds failed to get triggered. So had to fix that, had to go in and add some support for IPv6 in there, and they are back up and running. Key takeaway I wanted to stress there is that some stuff has to be publicly exposed, but whenever possible, restrict who you are allowing to access that endpoint, just to minimize some script kiddie hitting a vulnerability or some type of exploit that can allow them into your network, and then you just got to go deal with that mess, right? All right, the next thing on the list, I have a client. This one's also in AWS. They've got an endpoint that allows you to make purchases, i.e. a credit card, enter your credit card number to pay for your purchases. It's in AWS, so it gets hit all the time. And somewhere along the way, someone has figured out that this thing accepts credit card numbers. And so attackers will just enter in credit card numbers that they've gotten from someplace and look for credit card numbers that will successfully validate, and then they know that they've got a live credit card and they can go off and use that credit card to buy whatever it is that hackers buy, or I don't know, maybe they're buying Bitcoin, who knows. So this causes a lot of problems for this company because they're showing a purchase that was from a valid credit card, but then the owner of that credit card is going to dispute that transaction and say, wait a minute, I never bought anything from these guys. So then the credit card processor comes back to this company, says, what the hell are you guys doing? Why are we getting all of these chargebacks from your account? And they take it one step further and say, look, either drive the number of chargebacks coming from your company down, or we're kicking you off of our platform and we will no longer process credit cards for you. So here's what we did. This company, this client of mine, has a WAF, a web application firewall. And this protects the endpoints. If you're not familiar with a WAF, it looks for different types of attacks and then blocks those IP addresses to prevent that attack from being successful. So we've got this Amazon load balancer. And with the WAF, you turn on logging for the load balancer, so those logs get written over to an S3 bucket. And then there's a tool in Amazon called Athena that allows you to write queries, like SQL type queries, against the files in that S3 bucket. What we're doing on this instance is querying the logs, looking for anyone who's hit these particular endpoints multiple times, because this is a type of product that you're not going to do a lot of purchases from this company. You're going to buy this product and you're kind of set at that point. You don't have repeat purchases. So we're looking at the endpoint where we have a single IP that is attempted to make multiple purchases, and if it exceeds a certain value, we're going to take that IP address and add it to the blacklist in the WAF. So any attempts from that IP address to access this site again are just going to be automatically blocked. And now there's some different scenarios there. So like maybe you're trying to make a legitimate purchase and you type in your credit card incorrectly, or your credit card has expired and you have to get a different credit card. You know, there's a couple different scenarios like that where you might hit this purchase endpoint a couple of times, but within a 5-minute period, there's no valid reason why you should hit this endpoint more than like 2 or 3 times. And so we're going to ratchet this number way down on there and just block anyone who exceeds that. And if there's like a legitimate reason where somebody needs to access it more than that, I'm going to be honest, I really just don't care, because it would be very, very strange and very, very unusual for that to be the case in this scenario. But that takes us back to the whole OnlyFans thing, because this is where like the business of DevOps starts to meet with the business of being a business, right? So we're dealing with credit card transactions and chargebacks and using the firewall to control access to that and trying to minimize the number of chargebacks. And so here's what I think happened with OnlyFans. Credit card processors like MasterCard and Visa and those guys, they don't care that OnlyFans is selling porn. They're not going to take like their millions of dollars and go, oh no, oh, your porn is so offensive, They don't care. What they do care about though is when they have to do something, right? If the money's just flowing in and they just get to cash it in the bank, they don't care. But when it comes to chargebacks, that's going to cause them to take action, because now they're having to do actual work to make their millions or billions of dollars, right? And here's how I think this is going down, just based on things that I've seen in the past. A site like OnlyFans is going to have a large number of people who are using fraudulent credit cards or stolen credit cards just because of the nature of the industry that they're in. The other thing, which I think is probably more relevant, is you've got a portion of their fan base, and let's just be honest here, you've got a bunch of horny old dudes that are signing up on OnlyFans and doing whatever it is you do on this site, and then their wife opens up the credit card statement and sees this huge charge from OnlyFans. Well, the dude's going to be like,
oh my God, that's a pornography site. This is horrific. We've been hacked, Wilma.
And then Wilma's going to get on the phone, call a credit card company and say, somebody used this card at OnlyFans and it wasn't my husband because he said it wasn't him. And so now the credit card processor has to go and do a chargeback to OnlyFans, which costs them time, it costs them money, costs them aggravation. And when you reach a certain threshold, the credit card processor contacts companies like OnlyFans and says, look, either you get your shit together or you get your shit on down the road to somebody else. So that's kind of what I think's going on there. And I say that because I've seen that in the past due to other things that I've done in my career leading up to this point. And I just thought it was interesting. I thought it would be helpful for you to understand, that overlap, because the business of DevOps overlaps with the business of business. And whenever you refine your skill set into the place where those two circles merge together, you make yourself a very, very valuable asset to businesses everywhere. So I hope you found that helpful. Let me know your comments down below, and I'll see you on the next video.